lighter in tone, it'll be easier, I promise. So don't be miserable, please. We're almost there. Although this is about feature engineering, which is an extremely important topic, but we won't have much time to explore all of it. So I was just going to give you some of the basic tools to perform this in a nicer way, but I won't give you the details about which are the features we should use, because that will be dependent on each use case and each problem you may have. So I just want to give you some of the tools about feature engineering, and also to understand more clearly the types of data that we have in pandas and in data science problems in general, okay? So happy data sets are all alike. Every unhappy data set is unhappy in its own way. And this will become clear as we go through this presentation, what this means, I hope. So the motivation for this presentation is how to deal with different types of features in a data set. As you've seen by now, you may have numerical data types, you may have categorical or string-based, date times. There's lots of things we may need to consider in terms of types of features. And also, as long as you're clear with that, some of the features that come in your data sets may not be very useful when you're trying to create a machine learning model. Sometimes you have to transform them in some way. We've seen, like yesterday, if you remember, the log transformation, which was a good way to deal with outliers, you remember? But there are many other kinds of transformations you can do. And in particular, there's ways to make those transformations much easier to implement, as you'll see. So today, in summary, or in the next 50 minutes, I'll cover the types of statistical data, dealing with numerical features, and dealing with categorical features, okay? Let's start with the types of data. So as it was mentioned also yesterday, and I just want to recall this, there's this concept of tidy data, which I think she introduced yesterday, where each variable forms a column. So each field, each feature, there's different names for that. Each observation that you have forms a row of your data set, and the whole thing together forms a data frame. So each type of observation units forms a separate data frame. And in many cases, you may have more than one, and you have to deal with those in some way. The data set we're going to look at now will be an Avengers data set. And if you have no idea about Avengers like me, just look at the values. I really don't like Avengers, I don't understand. Anyway, but this was the data set was given to me. So here we have the name, if they're active, if their gender, the membership, the universe, the number of appearances, total deaths, and total returns, okay? And as you can tell, different columns have different types, clearly, right? Some of them are strings, some of them are numbers, some of them might be categorical, and that's what I want to explore with you in the next few minutes. So if you're using pandas, pandas have different types of data types. Can be objects. You've seen this a lot so far, right? Anything that can be text or even mixed types, doesn't have to be only text. You have integers, you have floats, you have booleans, so if it's something that is true or false. Date time, which I think we haven't explored too much, but you'll have time to do that, which are really something that pandas understand as being a date or a time, can be both of things together. Can be differences in time, so what we call time delta in pandas, and categories. And that's the thing I want to focus right now, the category one, which is a special one in pandas. Before that, if you have a data frame and you want to check the data types of your fields, so in this case the Avengers ones, you can just call the data frame. In this case, the data frame you've seen before, I called it Avengers. So, and you do .d types, and you get a list, or actually a series of all the data types you have for all your fields, okay? It's a quick way to check the ones you have. So you see the string ones, it will be interpreted as objects. The other ones were interpreted as integers because they're all basically just integers, okay? Categorical D type. So many of these, let me go back a bit. Many of these string things, you might actually think of them as categorical features. And categorical features usually call them the ones which have a finite, usually not very large number of possible values that thing can have. Like the name probably will be different for each of the observations of these data sets, so it really doesn't fit our notion of categorical feature. But the gender, for sure, probably have just male and female, right? So one of only possible two values. And also the universe. You probably don't have a different universe for each of the characters, you'll have just a bunch of them. And so this could be also thought as a categorical feature with a few values. And also here in our case, we also look at membership. which you only have 4 possible values, and you can consider that as a category, a categorical feature with 4 categories. Okay. So if I go back, what are the advantages of telling pandas that these fields will be categories instead of just normal object D types? So first, converting a string variable with a few values to a categorical variable saves memory, because you're basically just saying, okay, these are the possible values, and then you don't have to save each string for each object. So pandas deals with that automatically and can save memory, and that's important when you're dealing with big data sets. And by converting to a categorical thing, an extra thing we can do is actually assign an order to the categorical field if that category has a natural order, which, as we'll see in a bit. Let's look at one that doesn't have a natural order. So let's look at the universe field. So for that, if you want to transform the thing that was of type object or as something as of type category, you just have to write as type and then category. Okay, so this is just calling the field and then just saving it as a categorical field. And this gives, oh, sorry.
So that way, pandas will change it automatically.
Yeah, automatically. I actually didn't show you here, but then if you repeat the D types afterwards, you'll see that that one now will be called a category. Okay, and this will give you a few extra things. So if you actually, let me do like this, I think. So here, if you then write .cat, you get some extra options that you didn't have with other kinds of data types. Namely, if you write .categories, it will show you all the possible values. This is similar to .unique that you had before, which works for every single type. And also, you can check, there's a property called order, which will tell you if this categorical feature has an assigned order or not. In this case, it doesn't have. Sorry.
This underscore cat chapter, because it's object in the second line, it's supposed to be the same as the first one. To go from Avengers,
No, this is just a name. Yeah.
To go from Avengers to Avengers.
Yeah, sorry, there's a typo here. I forgot. Yeah, this is a copy of the original data frame that I created. Sorry, you're right. So imagine here,
Can you repeat the question, because I think that
no one listens. So from the first line to the second line, there's a he underscore cat. That's because I changed the name of the data frame, but here, when I prepared the slides, I forgot to show that. Sorry. So if you want, disregard this underscore cat, please. I'll correct the slides so that you have the correct version. But this .cat is actually a pandas thing. So it's a pandas method, which allows you to get these categories and ordered methods. Okay? Any questions so far? Sorry about the confusion.
Sorry.
Yeah?
So the universe column before the data type was like string.
Yeah, so first was object, right?
Okay.
There.
It was a string.
Yeah, so it was a string, and here in this line I changed to category.
Okay. If we print the data frame, it will be
Exactly the same. It will look exactly the same.
The difference is that the values are not characters anymore, like a number.
Yeah, in the other hood, will just be optimized because it'll just consider these categories instead of just saving each string every time. But from your point of view, it's just working with that.
The visualization is
exactly the same. And the way you work with the data frames is the same. You just get these extra few methods that you didn't have before.
Cat is a method.
Yeah, so cat is just allow you to access methods like categories and order, which are only present for categorical features. Okay? Okay. And this is an example of a categorical feature which doesn't have a natural order. But we can think of others which you may want to attach a natural order. Let's suppose the membership one, the membership field that we had before. And let's suppose that's the order that we want to give to the kind of type of membership you have. So honorary first, like the lowest category, then academy, then publishery, and then full. So how do you do that? One easy way is just write a list with the order you want to assign to this categorical field. Then say that you want the membership field of the data frame Avengers to be of type category, as before, just like in the previous slide. And then now you can access the .cat thing, because now it's a categorical field. And now you have this method called setCategories, where you give the order you want to give and just explicitly say, this is by default, but here I just want to show that you're just explicitly saying that this has an order. Okay? So what does this do? then this field membership now is also a categorical feature, but besides as a natural order given by this. And so now you can do things like ask for the min of this field, which you wouldn't think makes sense in a string field, but for a categorical field with an order, it makes sense, because now the minimum is the honorary. The max is full. You can even do, you can have a few others as well. Of course, you cannot do medium, the mean, or median. But you get the order, or you get a categorical field with an order. Does this make sense so far? Okay. Sorry about a bit of the confusion with the names, but it's not more difficult than this. You just need to learn how to change the type, because pandas by default, when you read from CSV, will not think of something as categorical. And if you have an order that you want to assign, you have to do it explicitly. Okay? So that's enough with categorical features. Now I want to introduce ways of dealing with numerical and categorical features. And for that, I need to introduce a concept, which I hope becomes obvious to you. If it doesn't, please let me know, because this is really important. As we've seen so far, many of the times you'll be dealing, when you're creating machine learning models, you're going to split the data into at least a train and a test set, right? That's something we've been exploring the last few days. And sometimes you want to do some transformation to the data. And sometimes that transformation depends on some characteristic of the data itself, right? Sometimes, let's think of something simpler before. Let's suppose you have your data set, you have missing values in some column, and let's suppose it's a numerical field, and you just want to fill with zeros. That's fine, right? You learned yesterday how to do the fill NA, for example. You just fill with zeros, and you don't have to worry about it anymore. But let's suppose you want to be a bit smarter about how you fill the data, or you fill the missing values. You want to fill it with the median, okay? But now you have a train set, and you have a test set. How do you fill these things with the median? So here I think you have two steps. The first one, which I think is quite obvious. So if you're going to do this separately, you look at the train set, you look at that column, you compute the median, and then you fill the missing values with the minimum of that column. Does everyone agree with this? Okay. So now I have a question. What do you do about the test set?
You ignore those missing.
I ignore the missing values?
Observations of missing values.
Sorry?
You have to do the same.
What does that mean?
So you fill the missing values with the median of the test set.
Okay.
And then
Do I have any other suggestions?
You compute the median of the whole data set and then fill in the test.
Okay.
Sorry, the missing value is for a feature or for
Okay. But
the true class of the observation?
okay, let me do here a figure. Okay. People seeing the recording will not see. That's the thing. Let's suppose here you have some column, some numerical column. Okay. Okay, and I'm going to split the data. Let's say like this. This will be the train. And here the test, right? And here now you have several rows of data. And let's suppose here a few are filled, but some are missing. Okay? Let's suppose the X means missing values. And the same from the test data, right? So what I think we agreed is that for the train set, so the separation is somewhere here. For the train set, I'm going to compute the median of all these values that are present, and then, so let's suppose that I call this the median, and then I fill it here with the median for the train set. Again, does everyone agree with this approach? Cool. So I'll ask again, what do you do here? Do I fill this with what?
You compute the median of that category. The
Okay.
category that
Over-
it belongs to.
over which-
No, only test.
Only the test.
Yeah.
Okay. Who agrees? Hands on the, yeah. Okay.
Can you repeat?
Oh, sorry. So I think the proposal was I compute the median over the test set, the values which are present in the test set, and then I fill this in the test set. So you said it? It was that. Oh, was that what you said?
No, no.
Oh, sorry.
100%.
Let's do it again.
So I want to fill. I want to use the median, but the median of which of the category that it belongs to.
But in the test set?
In the test set.
In the test set.
Yeah.
Okay.
How do you plan to do it when you get an observation? You want to, I mean, when you are in production,
Exactly.
you get an observation with a missing value. How do you plan?
That's the important question. That's really what I'm trying to get. Exactly. So let's suppose, yeah, so let's suppose this is your new observation. So you've done your training data test, and then you have your very good model. Now you're going to production, so there will be a new event coming in production, so one line only. And it's missing that column. So I want to know what do I put there.
Why not ignore it?
By ignore you mean not fill? Okay, but then you do the same in the train, right?
No. Ignore what?
The missing value.
The missing value.
But then you do the same in the train set.
Yes.
Okay, so that's an option.
That's an option.
Yeah, I can.
So that would be the same as just removing the feature entirely from the entire workflow.
Or just leave the missing values. So you can leave the missing values, but then you may have algorithms that don't like having missing values, right? But it's the same as like putting zeros, right? Like imagine the numerical values don't have zeros, so I put zeros and it just
So
stays.
there is the point. If you have, for example, 10 features for each observation, and if you have one missing value in one of the 10 features, because you have a missing value, you are throwing that observation away.
Okay.
You are losing information.
Yeah.
Because there were the remaining 9 features, you had some useful information there.
Okay.
So maybe it's a good idea that
Yeah, yeah.
use those values.
True. So let me be a bit more dictatorial. So I demand that I want to input with the median. So you don't have any other choice. Okay? So let's start with the decision tree goes into, you're going to do this. Now there's a split here, apparently. Some people agree on what to do it here. So we agree that on the train set, we just use the median on the train set. Here I want to know what you do with the test. So some people propose, let's use the median of the test. Some people are proposing, forget about it, but I want the right answer.
All the data. Median of
all the data. So let's do first proposal. So it's median of the test. Second is median of all. It's like this. And 3.
So, as your model is trained on the trained data,
Sorry.
as your model is trained on the trained data, maybe you can use the training average.
So the train? Okay. Third proposal.
Why not the random number?
Huh? No. I demanded input the median, so that's outside of the possibilities. I'm sorry. You're fired.
There is also an answer of the median of the category of that's very, very close.
Okay.
So, for example,
No, the median is across the column, right?
so you have a missing value for a record in the test set, and this very value belongs to, let's say, a category of maybe through nearest neighbor or something. You could get values that are similar to it in terms of properties, like maybe 7 or 8 features kind of correlate.
Okay.
You actually have an average of that for that very missing column. And
Okay. I agree. I think that's something you can do. It just goes away from my requirement that has to be the median. It's just an academic exercise, of course. But okay, let's not spend more time on this. The right answer is number 3, as you can imagine. So this cannot be done, or can be done, but will be wrong. So the thing is, why are we splitting the data into training tests? And I guess that's the thing that's still not clear for many of you. We're doing this because you're going to use the test really at the end, right? You're going to pretend the test set does not exist. You're going to develop your training, you're going to develop your model using the train set. It's like you have to pretend your train set is your available information, the thing you're going to use to explore, to do even the data explorations. When you start a data science project, you should do the data exploration in the train set. Because if you're doing the data exploration, you include the test, you're already cheating, because you already know stuff that you should have been looking at. Okay? So you're actually developing all the model here, You don't, all the information you can get is from the training set. The test set is like to pretend that this thing will go into production. You want to make sure that the model you develop will work well in production, so at this level. So you need to hide some of the data so that at the end, after you finish your model, you can test your model, okay? So here, when you're going to test, you've already trained your model, you're going to test, you're going to do the prediction and see if the model is working fine. Here, the only thing you can do, if you're being honest, is just use the median of the training sets.
Unless you are just competing on Kaggle. If you are to whatever you want to and use as many stuff in Kaggle.
Oh, yeah. Yeah, but in Kaggle, eventually you're going to have a blind set, right? Yeah,
Okay.
which you can do.
You are doing a data science competition and you have a fixed test set and you just want to perform really, really well in the test set and you don't really care if you have a low generalization error or not, you can do this. Otherwise, leakage is really bad for you because you are underestimating the generalization error of your model.
Yeah.
This was the section called How to Cheat.
It's how to cheat, yeah, exactly. So at the end of the day, if you're actually in a real data science project, your model is going to production. You really want to be sure that the model is going to production is going to react well with the information you have. That's why you should do this.
But then you're just worried about whether your model is performing well, not actually about whether you're representing or you're adding the most likely data for reality.
True.
Because your test set might have a completely different median to like the whole population.
Agreed. But if that's the case, then your test set is not really a good test set because the distribution of the data, the sample of the data is really different from here. And if that's the case, it's a problem that comes before even all this discussion. Like ideally, your test set will have very similar data to your training set.
Yeah, but then it shouldn't matter that much.
Yeah, at the end of the day, maybe the difference will be 0.0 or 1 or even 1. It's just the principle, the concept that is behind it.
If there is a difference, though, you definitely want to find out when you're in your Jupyter Notebook training before you go into production.
Yeah. That's why you have the test set, right?
Exactly. That's why you would want to use it on the train set. That's why you would want to use the median on the train set, is because if it doesn't even generalize to the test set, it's definitely not going to generalize to production.
Exactly.
It's a very good point, though. So I want to elaborate on this, that it's a very good point that every once in a while, the data set that's been made available to you is only a subset. Oh, sorry. It's a very good point that sometimes the data that's available to you is only a subset, and therefore you might actually know that the median is another value because you know that you only have this tiny sample. And then you could actually want to use business good sense to say, okay, this actually makes more sense to better the number. So always use your common sense. However, please don't let leakage from the test.
So in the applicants, can we shift?
You won't be able to.
I think already we have the first student who's going to be kicked out of the academy.
I mean, if you do, you'll submit your code, you'll give a presentation. We will judge the presentation. That's about as equally as weighted as your. So yeah.
Again, the hackathons will not. Hackathons is like Kaggle, right? So whatever.
Hackathons are like Kaggle, but you have to justify why.
Yeah. But you have to justify. Yeah. If you work in a company and you can see how things will go wrong for you. Okay. So going back to here. In the test set, you fill the missing values with the median you obtain for the train set. I hope this point is clear. And okay, so this was the concept. Now let's go back to codes. There's something called the transformers, which are available in sklearn and other like packages, which allows you to perform this idea in a very simple way and uses the kind of stuff you've already been using so far. So let's suppose that we have a transformer that applies the median of a column of your test set. You could use the fit to get automatically the median for the training set. So if you apply the fit just to the training set, and then you can just, after doing that, apply the transform to the test set, and will automatically take care of using the right value in the test set. Okay? This is a bit abstract now, but now I'm going to show you a series of examples where you'll see these very clearly. Okay? So starting with numerical data. And I'll go fast. Let me know if something is not very clear. So when you have numerical data, there are some kinds of transformations that are usually done. Let's start with the easy ones, discretization. So you may have a set of continuous data, and you may find that it is useful for some reason to split it into intervals or bins instead of just leaving it like continuous. This can be very useful, for example, if you have outliers, as we discussed yesterday. So if you have, in numerical data, if you have outliers, just making the outliers go into the last bin may be a good way to deal with the outliers. One way to do this is using one of these transformers. So the first one I'm going to introduce is the k-bins discretizer. And the way you use these transformers are always the same. So I'm going in detail in this first one, and then all the others will see the idea is the same. So first, I'm going to just, in this case, I'm going to use the appearances column in the Avengers data frame. So here is like choosing this one. Then you have to initialize the transformer. So you have to give it a name. Like here I call it pinner, call it k-bin discretizer, and then use the options that you have available for the specific transformer. If you remember, I think we talked about this at the beginning of the afternoon. If you use Shift Tab in Jupyter Notebook, you'll have automatic access to all the options that you have. So here, for example, I'm saying I want 10 bins, so 10 bins of the numerical data. I want this to be ordinal, so like in increasing order. And the strategy is that for each of the data, I'll just uniformly distribute that into this ordinal thing. You can then, if you want, just go into more detail of Shift Tab. Shift Tab. So sorry, maybe it was too quick. That's fine, that's fine. So here's just the options that you have for your transformer. Then here you feed to the data, in this case X, and then you transform if you want to apply. So here in this, just to be sure on this point, here I'm applying the transformation to the same data set. So here is basically, is like X is all the data set, and now the new column, which is the transformed one, will be here. Okay? If you were doing more the test and train thing I was doing before, you just do the transformation here. Okay? But here, just to show you how the code works, I'm doing it in all the data sets.
The output of the transform method is a data frame that only uses the columns that it can use.
Yeah.
It doesn't select the other one.
Yeah. So in this particular case, I've just selected one column. So it's a data frame with just one column here, if you see. So this double bracket notation means data frame with one, in this specific case, one column. You could have here more columns if you wanted. And so here, in this case, the output of this transform will be also a data frame with one column. But if you add more, you have more.
Yeah, because the input of that function is the whole data set.
Yeah.
It might be a bit confusing. I was expecting that X in the end to have the column on.
And it does?
No, the last X, I was expecting to have
this?
the X of appearance, for instance.
I'm not entirely sure I understand your question.
No, it's because he's thinking like the last X is the data frame completely, so
no,
yeah, but it's not mentioning the appearances, I think.
Because the feed knows what's the column that it needs to treat.
Yeah.
No, just one column.
But
yeah,
sorry.
It's redefined earlier.
Yeah. Again, sorry.
If I use the Avengers instead of X, I have a cat never.
Not necessarily, but it depends on the transformer.
So just to be clear, in this case, it's the same thing. But when you use the binary transform, the output will not be a series or a data frame. It will be an NumPy array, which is slightly different. We will go into that in due time. If you assign it to a column, to a data frame column, just like that, it's the same thing. But if you use only binary.transform, the return will be a little bit different from what you guys are used to. It's an NumPy array. So just for be aware.
It's true. Yeah.
And if you do feed on a data frame that with like two columns, that will work.
This depends on, I don't remember exactly if this one allows, but it depends. You'll see there's some transformers which allow to have several columns. They will treat each column individually. This one, I think you should have, if you have different numericals, you should treat them individually, but I'm not entirely sure. And maybe but even remember, the way you initialize this, you want 10 bins in this case, and maybe for the second column you don't want 10 bins, you want 20. So you have to initialize different ones. So here, by the way, in the rest of the presentation, I'm always going to show one column just to simplify, okay? So the X will always have one column. Sorry for that again. So the result of this, so the code you'll see always have this structure, And the result of this will be something like this. The previously continuous field now is discretized into bins. Okay, and I asked to be between 0 and 10. 10 bins between 0 and 10. Okay. Now all the other ones will look very similar, as you see. Let's suppose instead of 10 you want just 2. If you want just 2, you can do the same as before with 2 bins, or you can use something simpler, which is binarizer. And if you do this, you just have to define a threshold. So here I think I'm using again with the number of appearances. So I'm just saying, okay, if the number of appearances is below 1,000, go to this. If it's above 1,000, go to this. So now you have a new column which just have 2 possible values, 0 and 1, depending on the number of appearances you have in your data set. Okay? The structure again is the same. You initialize the transformer with the options. You apply it to your desired data set, or in this case, the column, and then you transform it. And in this case, I'm adding the result to a new column. Okay? Now, this was just transforming continuous data into discretized data. One thing that we've talked about before, I think yesterday, was about scaling and normalizing data. Especially if you're not using tree-based algorithms, as we discussed this morning. In many machine learning algorithms, having numerical data with completely different scales may really impact the performance of your model. Because some numerical thing will go from 0 to 1, and another goes from -1,000 to 3,000, and we'll probably just think this one is more important because 1,000 is bigger than 1, or something like this. So you really want to make sure that you do some kind of scaling in those numerical fields. There's many ways of doing scaling. I'm just going to introduce 3 of them here. The min-max scaling, the standard scaling, the robust scaling. They're all very simple, so keep with me. First one is you have a numerical value that goes from, I don't know, 0 to, let's not to 0, let's go to from 100 to 300. But you don't, so goes from here, x min is equal to 100, x max is equal to 300, but you just want it to go from 0 to 1, I don't know, like this. So if you look into maths, you can find a formula that transforms very easily this range into this range, but you don't need to worry about maths. There's one scalar called mix-max scalar. You just need to say, my desired range at the end is 0 to 1, and then use the same recipe. And we'll create a new field, which now the numbers will be in between 0 and 1. 0 if the original number was 100, 1 if the original number was 300 in this example. Is that clear? Okay. Next one, and the result, so in this case would be from 0 to 1. So the data will look like that. Then standard scalar, this is what we usually call the normalization, normalizing the data. So you're basically taking the median, the mean of your column, dividing by the standard deviation, and you get something new. So the transformer that accomplishes this is called standard scalar. And you do the same, initialize it, apply it to the data, transform it, okay? There's a few options here, you can explore that on your own, but the standard one, if you don't do any options, just use this. Okay, as we've talked about in SLU4, if you remember from this score, sorry?
Is that called z-score?
Is z-score, yeah. That's exactly the case. If you remember from yesterday, we mentioned that means and medians, you remember, medians were better for outliers. So sometimes if you're dealing with a column which has lots of outliers, one thing you may want to do is to use the robust scaling. And in this case, we just subtract the median instead of the mean. It's the only difference. And if you do that, to be able to do that, you just use this robust scale instead of the standard scalar. And again, as you've probably seen by now, recipe is the same. Okay? Again, and this is one is slightly better if there are outliers. Okay, and this is the result. Okay, 2 more slides for categorical fields. Okay, is this fine so far? I know it's too much information, but you'll have time. As you've seen, the code is always the same. You have to do it once, you learn how to do it once, and then just repeat the recipe. Categorical fields. You've probably seen, like many of the machine learnings we're using, assume, especially in the scikit-learn package, assume that the input fields are numbers. So if you have like strings and categories and so on there, the machine learning is just going to say, we don't like this, we want numbers. So what I'm going to show you now is 2 ways of decoding categorical features so that you have numbers as inputs of the machine learning model. So the first one is ordinal encoding, and it's as easy as it looks. You just, for each of the categories, you give it a number. And usually ordinal means you go 1 to the number of categories you have. So for these, we use an external package, which is really, really good. Don't use scikit-learn for this, for any categorical features encoding.
Sorry.
Yeah.
As type category, the method of the data series of the series that we have seen before, doesn't do this automatically?
I don't think so, right? At least no. Okay, not even more recent versions. So no, you have to do some kind of encoding before. Okay, again, as I said, scikit-learn has some kind of encoders for these. All of them are awful, so don't use them. Use these external packages called category encoders, which do more or less the same thing, but correctly and without many errors. There's 2 of them. I'm going to show there's more. You can explore the library then. The ordinal encoder, again, the syntax looks the same. All of these are done in a way to look the same all over. And the way they do is exactly as you see. For each, in this case, we're doing this for the universe category. If you remember from the beginning of the presentation, we're just saying, for this category, give number 1, for this category, give number 2, so on and so forth. So at the end of the day, if this was a categorical field, and this was like, I don't know, the 616, the new field would be 1. If it was the last one, the 13034, 7. So your new field would be numbers, right? And then that kind of thing can go to the machine learning model. Okay? Any questions on this? Okay. One more slide. The only problem with this, one of the problems you can add with this ordinal encoding is that the machine learning model is going to look at these numbers and might think that, I don't know, number 7 has some meaning, is maybe better than number 1. And maybe if you look at here at these categories, there's, as we've seen, these ones, then there's no natural order for this. Maybe none of these are more important than the others. So you don't want to bias the model to think that maybe universe number 7 is better or more important than universe number 1. So here you have another option, okay, this is just the result of, I should have shown this. You have another option, which is using one-hot encoding. And here, the output, instead of being just one more column, will be, if you have n possible categories in your field, now you'll have n+1 new fields here. And the way we do it is very simple. And let me just show you the result, and I'll show you the code again. It's just for each of these possible universes, we just create a new field and be a Boolean field, so 0 or 1. So in this case, if for this instance of the data frame, if the universe was this, the 616, this would be 0, it would be 1, otherwise it's 0. So in this case, these 2 instances have this universe, or this one has this, so on and so forth. Is that clear?
Sorry,
I can talk to you a bit after the slides, why, or even better, just try it.
Sorry?
If you want, try it. And then thank me for not using it.
That's the sole reason we use.
Yeah. You can ask students from the batch to how much they suffer with this. But I can talk to you after if you want, because otherwise I'll be here 10 more minutes. So this one, in particular, the main reason is actually this, is that this library takes into account if there's new unseen data. And this will be particularly relevant when you're doing with train and test division. So here, in your training set, maybe you have, I guess in this case, 6 categories, right, or 7. You have 7 categories, but maybe in your test set, there's a new category that the encoding thing never saw. So if here you have 1 to 7, and here you see an 8th category, what does this transformer do? If you use the scikit-learn 1, it will just crash. If you use this one, we'll just attach it to a new category. In this case, it's called -1. So we'll put all the things that it has not seen before in its special category. And then you may want to decide if that's okay with you, if you want to change things. Maybe you forgot one category at some point, but at least the thing will just work and not crash on you, okay? And in terms of the code, again, one autoencoder, same recipe, okay? So this presentation took way longer than I expected, sorry for that. But here as a recap with all the things you'll need to use for this unit and for the exercises, so do the exercises.